We're going to solve, graph, and check two-step inequalities. This is actually going to be the same key points that we've had for any solving of one-step inequalities. So, is there anybody who remembers one or both of the key points that we are going to be needing today? Leslie? Kevin?
Division of the negative number, you have to switch the inequality.
Okay, if you multiply or divide both sides by a negative, have to flip the inequality symbol. Right, and our second key point, Judea? Do both checks. That works too. I wanted to also put in, get this one first, inequalities are solved same way as equations. And Judea wants to add the third key point, which I think is kind of important as well. Check with both checks. So we can check with both checks. One check checks the starting point, one check checks the direction. All right? So, as we use that, we can move forward into two-step inequalities. There's not going to be any difference in what we're doing today than really what we've been doing over the past 2 days, except for our inequalities have multiple steps rather than just one. So looking at this first inequality, what is the first thing that I need to do to solve this inequality if I'm going to treat it just like it's an equation? Ian?
Simplify the addition first.
Simplify the addition. Can't make that any more simple.
Adding a negative, like...
He wants to do the inverse, so he's adding a negative 24 to both sides. So he's dealing with the additive inverse first, because remember, when we solve equations, we do them in reverse Pemdas order. So we always deal with additions and subtractions first. That gives me left over on this side is 3x is greater than 9 plus negative 24, that's negative 15. Raven, what do we do next? Sunny, what do we do next? Divide by both sides by 3 to get the x alone. So that gives us a 3 over 3, which is 1. Is greater than negative 5. Kip yes or kip no. Was this a situation where we should have flipped the inequality symbol? Everybody should be answering. Was this a situation when we should have flipped the inequality symbol? Okay, I see almost everybody responding. And those of you who are responding are showing me no. So you see that we're dividing both sides by a positive, so that means that we are not flipping the inequality symbol. So we want to do our first check. Our first check is coming all the way back to the original inequality, 3x. plus 24 is greater than 9. And we want to plug in the value we got here as our starting point. And remember, in this first check, we want things to come out equal, so I'm actually going to go ahead and replace that with an equal sign. And that's just for the purpose of this first check. I'm going to get 3 times negative 5 is negative 15. Plus 24 is equal to 9. Negative 15 plus 24, that's 9. And so that's going to be equal to 9. That's our first check. All right, so we want to go ahead and get this graphed. I'm going to start with negative 5. We now know is clearly our starting point. Please show me with an open or closed fist whether this is an open or closed inequality. Awesome. Everybody is showing me that this is an open inequality. So we should be looking at that. And it says x is greater than negative 5. So things that are greater than negative 5 should be off here to the right side. We do want to check that that is the correct direction to shade by plugging in some value on this shaded portion of the number line. Iron, what value would you like to plug in? 0. So he's saying that even though I haven't gotten there, at some point when we get down this line, 0 is going to be on our shaded portion. So he wants to plug that in. That's a really good choice because 0 is so easy to work with. So we're going to come all the way back to our original inequality again. We're going to plug in 0. 3 times 0 is 0. 0 plus 24 is 24. 24 is greater than 9. True, which means we're all good here. This is a correct solution. This is a correct graph. Any questions about either of the checks? Judea. We are fresh out of key points for now. But what would you like to put on your own personal key points? Yeah, so for the first check that it has to be equal. If that's a key point for you, something that you don't always remember, definitely put that down for yourself. All right, looking at the next one, we have x over 4 minus 6 is less than or equal to 2. Sage, what do we need to do first? So we're going to start with a leaf chain switch. Go ahead.
Instead of 4 over x, you do 4 over 1 because you don't want to cancel out x.
So this is where we have to be very careful. We have to do our inverse operations in reverse Pemdas order, which means we have to deal with additions and subtractions first. So we don't want to do that multiplication while we still got an addition inverse to do. So what do we need to do instead of that multiplication? Yeah, add a positive 6 to both sides. Remember, additive inverses always go before multiplicative inverses. So I'm adding a positive 6 to both sides. That leaves me with the x over 4 is less than or equal to 8. Now we can get what Sage was telling us to do. She was saying the multiplicative inverse here was to multiply by 4 over 1. And what that does for us is that gives us a top and bottom cancellation of the 4. Leaving us with x over 1, which is just x. Make sure we do that to both sides. 4 over 1 is just 4, so 8 times 4 over 1 is 8 times 4 is 32. We get x is less than or equal to 32. Yes, Sage? So, as we want to go ahead and check this starting point, we're going to write down the original inequality, just like we did on the previous one. Always starting with the original inequality for our first check and for our second check. I'm going to take our value that we think is the starting point. I'm going to plug it in. And for this one, we are checking to make sure that things are coming out equal. So I'm going to go ahead and take that. 32 divided by 4 is 8. plus negative 6 is supposed to be equal to 2. 8 plus negative 6 is 2, which is equal to 2. All right. And we can go ahead and graph this. 32. Show me with your fist. Should this be open or closed? Good. Lots of people with nice closed fists showing me this is a closed inequality because we have that or equal to portion down here. And it says x is less than 32. So when we have numbers that are less than 32, hopefully they're in this direction. These would look like the numbers that are less than 32. And so when we're looking at this, we need to find a number that we can plug in to check. So what number that is on the shaded side should we be plugging in to check? Rogelio, what do you think?
0.
Rogelio says he knows that if we come somewhere down the line, we're going to run into 0 down here. And so he wants to plug in 0. And I think that's an excellent choice. So I'm going to come back again to my original inequality. I'm going to rewrite it down just one more time. I'm going to plug in 0 for x. I'm going to 0 plus negative 6 is less than or equal to 2. 0 plus negative 6 is negative 6 is less than or equal to 2. Everybody, kip yes or kip no, is negative 6 less than or equal to 2. There seems to be confusion when I say everybody kip yes or kip no. That means I want everybody to respond. Is negative 6 less than or equal to negative 2? Yeah, absolutely. So that proves to us that we did shade this correctly. Sometimes you're going to run into problems that don't ask you to do the graphing, but the graphing is a really important way to check to make sure that your inequality symbol is going the right way. So even if you're not asked to graph the solution, you should graph the solution so you can do both checks. All right? All right, let's look at this next one. Negative 5x plus 23 is greater than negative 2. Again, we're going to solve this just like it's an equation. So, Emmanuel, what's the first thing that I need to do to solve this? Yep, add negative 23 to both sides. 23 plus negative 23 is greater than negative 2 plus negative 23. So these two things cancel out, giving me negative 5x is greater than negative 2 plus negative 3, which is negative 25. And Raven, what do I need to do to finish solving this inequality? Divide by negative 5. That gives us a negative 5 over negative 5. That cancels out because that is a 1 times x, which is just x. Now, really importantly, what should I be doing here as well? Since I'm dividing both sides by a negative. Judea? Flipping the inequality symbol. So you're going to see me flip the inequality symbol here. Remember, I'm only doing that because the division is both sides by a negative. Negative 25 divided by negative 5 is a positive 5. I get x is less than 5. So we want to go ahead and start with our first check to make sure that starting point is correct. So I'm going to take that 5. I'm going to take the original inequality. Negative 5x plus 23 is greater than negative 2. I'm going to plug that 5 right on in there. And for our first check, we want to make sure that things come out equal. Negative 5 times positive 5 is negative 25 plus 23 is equal to negative 2. Negative 25 plus 23. Let's opposite sign subtract. Take the sign of the larger number is going to be 2, but it's also going to be negative. One of the most common mistakes I see in people's checks is that they'll tell me something like a negative is equal to a positive. Well, that's never the case. Make sure that you're being very careful with your sign rules. All right, so we know that 5 is our starting point. This is an open inequality. We have x is less than 5, which means that we should be shading to the left. Six and 7, 3. And what value would you like to plug in to check here? Leslie. 0. She says that if she comes down the line, eventually she's going to run into 0, which is an excellent choice, always. Negative 5x plus 23 is greater than negative 2. That's my original. She's telling me to plug in 0 for x. Negative 5 times 0 is 0 plus 23. It's greater than negative 2. And this tells me that 0 plus 23, which is 23, is greater than negative 2. Gerson, kip yes or kip no? Is 23 greater than negative 2? Yes. Absolutely. That wasn't a kip yes, though. Next time, let's focus on following kip yes or kip no. All right. Any questions about this problem? This is probably one of the most missed problems in 7th grade, definitely in the top 5 because it is a flipped question. So moving on to this last one. This one also gets really confusing to a lot of you because you see the x on the right-hand side of the inequality. You can turn everything around first thing, but I want you to learn to solve with it on the right-hand side. Leslie, what's the first thing that we should do here? Leave change switch. So no matter what side of the inequality or equation that the x is on, we have to make sure that we're doing inverse operations that have happened on the x side. So what inverse operation should I be doing here first, Leslie? Yeah, add a positive 8 to both sides. So we're trying to get the x alone. A lot of people here want to start adding a negative 4 to both sides. Remember, your goal is trying to get the x alone. So adding negative 4 to both sides does not get the x alone. It just clears out the left-hand side. So the adding positive 8 helps us get our x alone. We get 12 is less than 2/3 x. And now I've got 2/3 x. I've got one more inverse operation that I need to do to get x alone. Gerson, what inverse operation do I need to do here to get x alone? Multiply by the reciprocal. Very good. So we're going to take our 12, and our reciprocal is 3/2. So we have 12 times 3/2 is less than our 3/2, our reciprocal, times 2/3 x. That gives us on the right-hand side a cancellation of the 2's and a cancellation of the 3's, leaving just the x. And on the left-hand side, I can do some simplification here. This is 6 times 2, so my 2's will cancel out, and I'm going to get 18. I get 18 is less than x. Now we're at a point where a lot of you look at this and you go, I don't really like when my x is over there on the right-hand side. I want to be able to write this the other way. What's the other way I can write this inequality? Leslie. X, the little symbol thingy. Which little symbol thingy do I need? Do I need it to open up to the x, or do I need to open up to the 18? Yeah, it's already open to the 18, so we need to, it's already open to the x. So if we want it to be the same statement, it's got to continue to be open up to the x. So this tells me that x is greater than 18. It means we think 18 is our starting point, so let's go ahead and check that starting point. As I'm always doing for the first check, I'm taking that original inequality and I'm plugging in my starting point. 2/3 times 18. I can do some quick simplification there. Gets my 3's to cancel out. Gives me 12 plus -8. And my first check, I want things to come out equal. And sure enough, 12 plus -8 equals 4, which is equal to 4. All right, now we want to go ahead and finish this. We have an open inequality. X is greater than 18. And Maria, what value would you like to plug in to check that we shaded the correct direction? 27. So she's saying she's coming way out here to 27. That's totally fine. Why did you choose 27? Okay, she's thinking about divisibility rules, and so what I think I hear her saying is that she knows that she's going to be having to deal with this 2/3. And it makes it a lot easier if you can do this cancellation. And so you get a whole number here. I think she was thinking even further ahead that 18 is a really nice number to work with -8 because it comes out to a nice even 10. So we get 4 is less than 10. Kip yes or Kip no. Did we shade the correct direction? Kip yes or Kip no. Did we shade the correct direction? So 4 is indeed less than 10, so that clearly means that we've shaded in the correct direction. All right? Are there any questions about your work today?